Good afternoon. Thank you for joining us. It's the last exercise in the final Better Hackathon series. So today it's Fraunhofer, EIS consortium member presenting and carrying out this exercise. The topic is semantic geo-clustering using the SANSA framework. And it's myself, Simon, and my colleague Afshin who will be mostly presenting and conducting the exercise. So very important to know that these links can be followed offline. So you can also fast forward if you like, or you can go back and look at the next slides if you're too fast. As a participant, you're not able yet to speak. We will switch to discussion mode after the initial introductions and presentations. Afshin, can you go back to the slides, please?
Oh, sorry.
Yes, so we will use the chat channel, which you can see. I'm going to send some introductory messages there, and also the links to the slides, okay? And please keep an eye out on this channel. You also have possibility as participant, even when you're not allowed to speak, but you will be allowed later to raise your hand and to ask questions, and we'll keep an eye out on that for you. And also, just because I'm doing this round, there will be also a secondary channel if there's some issues which cannot be fixed in the major rounds, rather than, if we need more time to fix something one-to-one, we will have a secondary channel to do that, especially in the beginning when we're setting up the Docker image. So let's proceed. So please, next slide, Afshin. So bit of a background. So I know some people here might be not the first exercise they're following, so I will keep this short, but I'll just tell you the most important stuff. So we're in the last 3 months of the Better project. It was one of the projects selected in the Big Data Shift. There's 5 projects. Last year we had a joint hackathon. It was very nice. We had many exercises because it was not only our project exercise, but we had more. So those are the partners we are presenting today. That's why we're in bold. But there's 2 other technical partners, Demos and Terradua. And we also have what we call as challenge promoters, because this project is very identifying challenges and then developing technical pipelines to address them. We had a lot of those, as you can see, but World Food Programme, European Union SATSAN, Satellite Center, and ETH Zurich were the challenge promoters. Next slides, please, Afshin.
So the general objective of the project is basically, as I said, to identify these challenges and pipelines. And you can still hear me? Maybe Afshin, sorry, because I had an issue with the hot headset all of a sudden. If so, I proceed.
Yes, I can hear you well.
So the idea is to identify data challenges, a total of at least 3 per challenge promoter per year. So that was 9 at least, plus some external ones. So in total, we had at least 36 throughout the last few years, but there were even more, what we considered as external challenges. And then the data pipelines were developed to solve these challenges. So next slide, a bit more information, a bit more graphic, right? So there's 3-yearly cycles, defining the challenges, identifying what is really important in the Earth observation community, how to use especially data from the Copernicus and Sentinel satellite data and satellite images. So this bit the process over 3 years. And next slide, just an additional remark. So we increased the communities, okay? So the community in Europe, Earth observation is quite connected, okay, and one of the additional objectives of the project was to extend those communities and also strengthen them. Because a lot of the challenges we identified in projects are of course useful or are also challenges faced by some of the partners. And here on the right you see other partners which were not necessarily partners in the projects, but which have been involved in the what we call the external challenges. So next slide, please. If you want more information, okay, you also have the offline link to the slides. Anything you like there to read more about the three thematic areas we have: food security, geospatial hazards, and geospatial intelligence. Those are the three, let's say, categories of the challenges and pipelines we identified and developed. But there's also our social media, the SlideShare account, where these slides are also included, and the YouTube channel. And by the way, the introductory part and some other parts of this webinar will also be recorded, so it can be followed at a later stage as well. Okay, next slide. What is the focus today? So the first three exercises in this final better hackathon, they were each organized by the challenge promoters. So they were very related to their thematic areas. So with security, geospatial intelligence, and geohazards. In this case, we are more of a technical partner, as you have seen in the introduction, and we specialize in semantic technology, interoperability, and knowledge graphs. So what we wanted to do and what we were doing throughout the project is to try also to keep the Earth observation community up to date with latest technology, in this case, semantic interoperability, and what can be done. So I will very quickly explain why this is important and why this is one exercise featured today. So the next slide, the basic message here is that there's many different data sets, different on the cloud. You can think about it like this, right? Provided by different people in diverse formats. And it's all very diverse. So the value of this data is, of course, higher if it can be processed and analyzed together to generate joint results and joint analysis to processing. So that's why semantic interoperability is important, because it addresses the heterogeneity of data. It makes it easier to connect the data and to generate insights from it collectively. So that's basically why this is important. In the next slide, again, a bit more, let's say, deeper into technology here. So we want the data, we want to have common domain models, okay, to define what the data is, the understanding of the data through these models. And this facilitates porting data, okay? You don't necessarily have to bring the data centralized, but at least know how to interpret it, even if it's remote. So that's a bit the idea. So to go from different kind of data formats to something which is a bit more or less heterogeneous, okay? And that's the message. We use vocabularies for that. So you can have metadata in addition to the data, and the metadata describes what the data is. So rather, for example, think about a table with columns and rows. There's clear understanding of what the columns and rows contain, what are the limitations, what are the restrictions, what values the rows or each cell should contain. And these are not only understandable to the person managing that table, okay, we're thinking about the database, but they are understandable also to a machine to an extent or another, so that when you port the data, it can also be ported together with the description of what the data is. And the description is much more easier understood even by machines. So this creates what we call semantic interoperability. And next slide, a bit more technical information here. One example. So we talk about a lot about triples when we're talking about semantics and semantic technology. We also refer to RDF. I'm not sure. who is aware of RDF, maybe this is a good opportunity, okay, to try out the hand raise feature. So I would ask the participants to raise their hands, okay, if they are familiar with RDF, to see if we need more support with this. So you should have the raise hands icon as a participant. Or if you face difficulties with this, if something is not the way it should be, through the system, there should be an option to raise your hands. So I see no hands raised, although I know some of you are familiar with RDF. So meanwhile, if there are issues with the system, you cannot raise your hand or similar, please ask a question, or you can also use the secondary channel, which is already active. Because I don't see anyone with a raised hand. Okay, now I see some are raising their hand. So one question again, if you're familiar with RDF and you're a participant, raise your hand. So I see some of you did, but let's assume that not all of you are familiar. So I'm going to give a very, very quick introduction because this is very important, because throughout the course of the exercise today, you won't really need to become an expert in RDF or semantic technologies, but you need at least an understanding. So the main way to think about this is you can think about a triple, which consists of a subject, predicate, and object, and all information and all knowledge even can, to an extent or another, be described using these triples. So we have an example here. We have a place. It's type province. It's actually a country. Sorry, it's in a country, and it has an amount of rainfall per year. So the center of this information, okay, there's different kinds of information about Bulawayo, which I understand is a place in Zimbabwe. The center is this Bulawayo subject. That's why it's a subject. And there's three triples defining information about it. So this is the basics of what RDF is. And these definitions, that it is a province, that it is a country, or that it is inside a country, and monthly rainfall, okay, these are defined by ontologies, which say that things like a place, yeah, can be in a country and it can have a monthly rainfall amount. So that's the kind of description which defines the model, let's say, the fact that places are within a country, the fact that places have a rainfall amount per month, and the actual data, which is in this case, that Bulawayo is an example of a place. In this case, Bulawayo is in country Zimbabwe and has a monthly rainfall, which is that amount. So that is the main distinction here, which we need to focus on. There's different kinds of objects. Some can be other objects, like Zimbabwe, which is a country, and others can be a number, which is 86, which is just a value now. Here is the amount of rainfall in presumably centimeters. So that's the basic concept of RDF, okay? We go to the next slide. The message here was data, metadata. Okay, the example was the data. We had something about Zimbabwe and Bulawayo in this case. And the metadata was this that is in a country, that a place can have a rainfall amount and so on. But at the bottom, this blue part is the vocabulary. So these are very important. So these are the ontologies, vocabularies, whatever you want to call them. They model domain. And in this case, Earth observation, okay, they have a general understanding between the specialists and the experts in this domain area. When we say domain model for Earth observation, they are ontologies which are dedicated to this field, okay? So they have things about, in this case, places, also satellite images, things that can be identified in satellite imagery, for example. So these could be domain models for the Earth observation area or domain. So that's the main message here. If we go to the next slide. In the meantime, I can also improve the sound, and apologies for that.
And a quick check, Afshin, that I am also, again, audible.
Yes, you are audible.
Thank you, Afshin. Okay, so the question was before, right? How can we bring different kinds of data together, even if we have these models? So assuming we have these models, there's ways how to do it. So once we understand that we have different data, but it's related because it's, for example, all about satellite images, we can bring it all together through transformation tools which exist, which can lift data from databases, from text files, from CSV, and so on, into something which is a bit more sophisticated in terms of knowledge representation, for example, a knowledge graph, okay? So a knowledge graph consists of basically a lot of triples, okay? So that's why you have those bubbles there with connections in between. So we can think about the previous example about Bulawayo in Zimbabwe, but you can have other regions in Zimbabwe, you can have other countries. In Africa, you can have other countries in the world, and you can put it all together to have, for example, a knowledge graph about rainfall in the world, okay? So that's the idea here. So once you have the data identified where this data is, even if it's different formats, through semantic transformation tools and through the important ontologies, which are the domain models, which define the metadata structure, you can generate such knowledge graphs. So a main assumption today is that this is always generally possible, and it is in most cases, okay? It's a bit more difficult in others. In satellite imagery, okay, we're trying to catch information from images, which is a bit more tricky than catch information from text, right? It's a bit easier, but it's still possible. So the storyline today, which we will hear about very shortly, is to try and connect image information, things that can be identified from images, things that can be written in social media, in this case tweets, and put this together in one RDF compliant format, okay? Once you are able to do that, you can think about it as a nice knowledge graph about what you're trying to derive information from, okay? There are tools like SANSA, and Afshin will tell you a bit more about SANSA, which are able to operate on a knowledge graph. So SANSA can use these triples, this RDF data in a knowledge graph. It can be configured, there are libraries, but it can do processing, it can do analytics. So it does analytics on semantic data, okay? So if you think about the story presented to you earlier, that we can have a way how to connect different data, no matter who provided it in whichever format it is, and then you can bring it in one place together, call it a knowledge graph, and have nice tools like SANSA, which do scalable analytics, even though it's really big, okay? And that's the whole power of SANSA. So that's what we want to showcase a bit today. Of course, we have a use case which is related to Earth observation and should be of interest to you. But SANSA is independent of this, is in domain, and also for sure, knowledge graphs are domain independent as well. So I think that's the main message. What is the next slide, Afshin? Yes, I can say something. Maybe Afshin, you can also take over. But what I was saying, introducing is this, right? So SANSA is an innovative knowledge-based inference framework, and it also has machine learning. So it does various functions. You can see there on the top left image. And for those who are interested, there's of course a website, which I will share with you also in the chat in a bit. But it does various reasoning, inference, okay? And that shows the power of going to a knowledge graph-based approach where all the data is structured. Okay, Afshin, I think you can maybe want to add something here, and you can also proceed with the next introductory slides.
Thank you very much. So I can add here that we have different layers, as in the image shows. In the down layers, we do queries and in-memory processing of triple type data that are based on RDF or all. And then on the top of that is the stage of the knowledge distribution or representation, which is performing the distributed data, taking and fetching, and on top of that, the query, the Sparkle queries can be run, and then on top of that, we have inference and machine learning layers. Thank you very much, Simon. I take it on from here. So I'm Afshin, working in Fraunhofer and University of Bonn. I'm a PhD student there, and welcome to today's exercise. We are going together to do the last and final better hackathon, and we are having a support with us. Hanton is going to support and be our angel for any problems that we have regarding the Docker in the beginning. So don't be shy, just click this link. I share it also.
I will share it. I will share it in the chat,
okay.
Afshin, don't worry
Perfect.
about that.
Thank you very much. So Simon, will you share it in the chat? We can anytime go to that second channel and ask any questions that you have regarding the setting up the Docker in your system. And hopefully you have the prerequisites. They are not much. I'm sure you will have it. And so from now on, I want you also to give me or to give the other participants a short introduction to yourself. So I changed it from meeting mode to the webinar mode here. So.
So meanwhile, yes, as Afshin was saying, ideally this was meant to be a face-to-face hackathon and event, but given the circumstances, we could not do this. Nevertheless, we would like it to be as interactive as possible. So also in a bit, we will ask you to, there's not too many participants, so we can ask you to briefly say something about yourself, and perhaps why you're interested and what do you expect to get from this exercise today. Afshin, do you want to proceed with the next slides?
Yes.
We can switch to meeting mode later, yeah?
Yes. Okay, thank you. So let's continue. So how will be the time plan today? Right now it is 1:57, and we will right from now we will start at 2 with the tasks already. So we imagine that you have prepared and set up the Dockers and did the commands make and make up. I just did it right that Simon was talking, so maybe you have seen that. I was on the other screen. And so that is ready. We will also do the loading and etc. So after that, we will, between our sessions, we will have 20 minutes for breaks. And so we have one or sessions at one that finishes at 3, the second one finishes at 4:10, and the third one finishes at 5:15. And we will have our talks and sessions, and between them also we activate the mic so everybody also can make questions or raise hands anytime and stop whenever there's something. So, and in the end, we will have the wrap up and the result and reports and the conclusion. Then we are 2 minutes early. If I could make it, people could talk, and so
I would, Afshin, I would say something about the exercise first. So maybe the next slides,
okay,
because then we can also get comments about
right.
that.
So then I continue with the next slide, because here we have the data. I have to explain it before the exercise. We have a data extracted from Twitter and the Twitter image, and if you see in the left hand side, there is a car in the street and there is some people in the seashore. So each of them are extracted from the image attached to tweets, and then there are the tweet posts. From them the geolocation have been extracted, so we also know the place of these images and the tweets, and we are going to cluster these tweets based on their type of the things that are inside the image and also their location. How that will happen? We will do it together. So that means that this is a joint type of clustering. So the process is that we will do 2 type of clustering based on one data, which is multidimensional. And this is the pipeline. So we first do the data transformation and then convert it to the RDF type of data on the data set. And then we go through step-by-step clustering based on the tags and geo tags. And then this clustering is done using SANSA stack, which is distributed type of processing that is using on the underlines, it is using a Spark. So the data, I should thank our friends from CERT that provided, kindly provided this data for us. This is small, but have all the content that we need. So it is easy for us to do the processing in this short time. So that this data set is extracted from the social media Twitter, as we said before. So that is was processed by collecting and also analyzing and then extracting the visual concepts. So all these processes have been done already on that, and we are taking just a small piece of that data. How does it look like? It is a JSON file. Inside that, you will see the tweets and the number of the tweets. They have IDs, timestamp. They have a image concept extracted from the image, and then that's the location, which is both in type of the place and also the geolocation, the coordinates. So what we will use that in this exercise is this coordinates and the image concepts. These two. This will be repeated. So this is for example, just tweets 0 and 1, and they have an ID. You will see that they have a long tweet IDs. So what we need that from here, we need the Docker Compose, and Linux operating system to do the exercise.